So, good afternoon, everyone. Welcome to the week 8 problem solving session for this course. So, today is the last problem solving session, and after this, you all have exam for this course. So, let's go through what was there in week 8, and then we will see the previous year questions. So, first, let me share my screen. So let's first see a brief introduction of what was there in the week 8 lectures. So the first lecture was on tutorials on transesterification. So we will see numericals based on this tutorial in the while solving the questions, while solving the previous year questions. So the second lecture of week 8 was cultivation of algal biomass and treatment of wastewater. So we will see these contents. So first, what is algal biomass? So algae is a photosynthetic aquatic organisms which uses like any photosynthetic organism. It uses CO2, water, and light to grow and increase its biomass. Also, algae is used in treatment of wastewater because they can take the nutrients from the wastewater and also they can take some amount of heavy metals and they can make the wastewater free of nutrients. So, but for treatment of wastewater by microalgae, there should not be organic carbon because as we can see from this reaction, that algae requires CO2, which is the inorganic carbon for growing. So if any system we have organic carbon, then it should be removed, or we can use bacteria along with algae to remove the organic carbon. So we can see that microalgae has vitamins, protein, lipid, carbohydrate, and carotenoids. That is, this is used for pigments and cosmetics. So lipid, we will see from lipid is the main component which is used for production of energy. So algae have wide application. It is used in health, it is used in food and feed additives, it is used in cosmetics, and it is used for energy production. So some of the advantages of algae is like it has very rapid growth. It can grow in both saline and brackish water. So in our sea also we can see macroalgae floating on the surface of the sea. In some of the species of the algae have high yield of lipid. Because of higher yield of lipid, we will get more energy. It use all nutrients like it takes nitrogen and phosphorus, and it can minimize the eutrophication. It requires CO2 for growth, so therefore it will be carbon neutral, and it can be used as a fodder and manure in the agriculture fields. So it has very diverse species and varied composition, and it is an untapped resource with high potential. So we need to do a lot more research on microalgae. So here it is the algal metabolism and synthesis of fat and protein. So it takes photons, light, H2 and CO2, and produce glucose, and glucose is converted to tag or lipid. And this lipid contained in algae contributes to bio-oil. So here it is the metabolic pathway of algae for biofuel production. Please go through this in the lecture slides. So here it is classification of the microalgae phyla. So some of the phyla are green algae, red algae, cyanobacteria, that is the blue-green algae. Please go through all these. Next is biomass and lipid productivity of different phyla of microalgae. So here it is a table given where lipid production and biomass productivity of each of the different algae is given. Next, here it is the lipid contained in algal cell is given. So various types of fatty acid in algal cell are given. Please go through these in the slides. So generally, it is seen that with the increase in algal lipids, there is increase in bio oil quality, which is given by cetane number. But we can see that there is some optimum uh, lipid amount which gives the highest cetane number, which is around C18. Next, monitoring of favorable fatty acid content in algal oil. So please go through these in the slides. So strategies for enhanced lipid accumulation of microalgae. So there are two methods. First is the physicochemical method. Here we can give nutrient stress. We can optimize the culture conditions, like we can optimize light, temperature, salinity. We can grow glow culturing with bacteria. We can grow algae and bacteria both. And we can use different carbon substrates. Next is the molecular strategies like gene silencing, transformation of microalgae cells, overexpression of genes directly linked to lipid biosynthesis pathway, gene expression analysis, etc. So here it is the flowchart which shows cultivation of growth of microalgae as an important step for algae to oil, because uh, um, here we can see the algae cultivated. Here the algae is grown in glass flask. Then the wet biomass is obtained. Then it is dried and then ultrasonicated by using chloroform and methane. Then the phases are separated. Here we can see the solid mass, and at the top we can see the oil, and then further separation is done, and then we have gone the oil. And finally, after transesterification, we got the bio oil. So please go. So this is the last slide. So we have been given cultivation or growth of microalgae. Here bioproductivity and lipid content formula is given. So let's move to the next slide. Sorry, next lecture. So here the reactor systems for cultivation and growth of microalgae is discussed. So different types of system are used. First is the open system photobioreactor. Next is the closed system photobioreactor. So major types of closed flow system photobioreactors are vertical tubular, horizontal tubular, plate or plastic bag systems. So here in the figure we can see a open system where the algae is grown, and at the top of this we can see it is used for collecting the algae, or it is used for concentrating the algae, and then it will be harvested. So first closed photobioreactors we will see. So it is a horizontal closed tubular photobioreactor where the fresh media is degassed and then it is passed through this horizontal tubular photobioreactor, and finally it is harvested. Here we can see a vertical column photobioreactors. So we can here, and here it is given a flat panel photobioreactor. So here a comparison of open and closed photobioreactor is done. So for open system, high space is required, and for the closed system, the space requirement is comparatively less because for algae grows in presence of light, so we cannot get deeper because so for growth of the algae we cannot increase the depth of the pond too much, because at the bottom it may be possible that light will not penetrate and algae will die or it will not grow. So that's why in open system space requirement is high. Also, because the system is open, there will be lot of water loss by evaporation. There will be lot of CO2 loss because there will be continuous exchange of CO2 between the water surface and the atmosphere, and oxygen concentration because there will be a spontaneous outgas with exchange of oxygen. And if you see in the closed system, then since algae is a photosynthetic organism, so it will produce oxygen and oxygen has to be removed from the system. Next is the temperature. For open system we cannot control the temperature, but we can control by increasing or decreasing the depth. But in closed photobioreactors we can control the temperature. If the temperature is very high, then we can keep it in some cooling baths, and if the temperature is very low, then we can heat the reactor. Next is the shear. So in open system the shear is very low or gentle mixing is done, but in closed photobioreactor fast or turbulent mixings can be done. Here again we can see for cleaning there is no issue in open system, but in closed photobioreactor we need to clean the walls and dirt because it reduces the intensity of light that penetrates in the system. Next is the contamination risk. In open system there is lot of contamination risk, but in closed system the contamination risk will be less because the system is separated from the atmosphere. Next is biomass quality. It will be variable in the open system and it will be reproducible in the closed system. And biomass concentration. So in closed system we can get a higher yield as compared to the open system. And production feasibility, if we see, then we can only grow few strains species, and in closed system we can grow lot of species. Next we will, here is a comparison of different photobioreactor is given. Next here the typical dimension for different typical dimension of the reactor is given. Next is harvesting of microalgae. So harvesting can be done by sedimentation, flocculation, flotation, centrifugation, ultrasonic agitation or filtration. So these are the methods for harvesting. Please go through all these. So for different species, different methods have been used and it is given. Please go through this. And here a comparison of some algae harvesting techniques are given. So first is the gravity sedimentation. It is not very efficient for rapid biomass recovery, and but the cost here is less. Next is the inorganic chemical flocculation. And next is polyelectrolyte flocculation. So some polymer is used which makes flocculant, which flocculate the algae and it settle, and then we can harvest this. Next is the centrifugation, but there is chances that during centrifugation some of the sensitive algae species may get altered because it is rotated very high rpm. Next is filtration. We can use pressurized filters. And next is the flotation. We can harvest the algae from the surface of the system. And last is autoflocculation. It happens in absence of CO2. So here some of the example of wastewater treatment using algae is given. So if we are using algae, then first the wastewater should be secondary treated to remove the organic carbon, because organic carbon hampers the growth of the algae because algae requires inorganic carbon. So after removal of the organic carbon, then the wastewater can be then the algae can be grown in the wastewater and it will remove almost all nitrogen and phosphorus from the system. So let's move to the next lecture. So 39 and 40 is on energy production from algal biomass. So here we can see important energy production route for algal biomass is like we can produce biodiesel, biojet fuel, syngas, bio-oil, pyro-oil. So after the algal biomass is extracted, we can do the oil extraction and then further we can do the upgradation. So here the bio-oil production from sorry. So the harvested algae is dried and further oil is extracted. Then separation is done is to extract the oil, and after the oil extraction, whatever is left will be the biomass, which can be used for agriculture or to give use as manure, or it can be also be given to the animals because it is very rich in nutrients. And after the bio oil is extracted, then it can further be improved. So this is the mechanism for oil extraction. Please go through these in the slides. So these are the examples for flowchart for extraction of oil. Next is transesterification. We can produce biodiesel from this. So here the mechanism of transesterification is given that triglyceraldehyde will react with alcohol to form ester and glycerol. Please go through these in the slide. So this is the last lecture of week 8. It is on energy production from algal biomass. It is continuation of the previous one. So here the upgradation of bio oil to diesel. So some of the examples are given where various catalysts have been used for upgradation of algal oil to biodiesel. So please go through these in the slides. So again the different for all the heterogeneous catalysts which are used. So heterogeneous catalysts are the one whose phase will be different from the algal oil. So we can see that methanol and methanol and methylene dioxide dichloride is sorry, these are the solvents. We can see that CO is supported Al2O3 and others are used as the catalyst. So here a comparison of is given. Please go through these in the slide in the lectures. So next is stability of the bio oil. So the stability is divided in oxidation stability, thermal stability, and storage stability. So please go through these, and these are the modification of the bio oil to biojet and some of the industries which are already extracting oil from algae. So please go through these in the lectures. Now we will s- now we will start solving the previous year questions. So let's go to the questions. Now it is sorted. So let's directly go to the question. So the first question is a numerical type question. The question is bio oil extracted from an oil seed sample has 90% triglycerides containing three long chains which can produce methyl esters of lauric acid, myristic acid, and palmitic acid in equal molar ratio during transesterification using methanol and NOH catalyst. Calculate the amount of biodiesel produced by a transesterification of 12 kg of bio oil. Assume the efficiency of the conversion is 80% and 10% of the palmitic acid is converted to soap. How much glycerol will be produced? So we have to calculate how much glycerol is produced in this reaction. So I will give you 5 minutes. Just take your time and try to solve this question, and then we will see how to solve this question. Okay, let's see. So we have been given methyl ester of lauric acid, myristic acid, and palmitic acid. So the formula of the oil will be CH2 O CO C11 H23 CH2. So it will react with methanol and it will give us glycerol and biodiesel compounds. So here it is given that around 90% of the oil contains triglycerides which can be converted to glycerol. So here basis is given as 12 kg of bio oil and triglyceride, sorry, it is triglyceride is 90% of the bio oil. So it will be 12 into 0.9. So it will be 10.8 kg. Now we will calculate the molecular weight of the triglyceride. So we have 45 carbon atoms. So it is 40, 12 for carbon molecular weight into 45. We have 86 hydrogen atom. So it is 1 into 86 and we have 1, 2, 3, 4, 5, 6 oxygen atoms. So molecular Atomic weight of oxygen is 16. So 16 into 6. So we are getting 722 grams. So we will calculate the number of moles of glyceraldehyde, number of moles of triglyceride. So we have 10.8 kg divided by 722. So it will be 14.958 mole. And it was given that efficiency is 80%. So efficiency for conversion is 80%, and so mass of glyceride that will be converted to glycerine will be it will be 80% of the total number of moles. So it's coming out to be 11.966 moles. So glycerine produced will be so we will have to calculate the molecular weight of glycerol. So it will be, I guess, around 92 grams. So let me first write the formula for glycerol. So glycerol will be CH2OH, CHOH, CH2OH. So molecular weight will be, we have 3 carbon atoms, so 3 into 12, plus we have 8 hydrogen atoms, so 8 into 1, and we have 1, 2, 3, 3 oxygen atoms, so 3 into 16. So it is 92 grams. So the amount of glycerine produced will be 11.966 into it is 92 grams. So It's coming out to be around 108.9.4 grams. So while converting to kg, it will be 1.0894 kg. So it is 1.08. So let's go. So A will be the correct answer. So here we have been given triglyceride, and around 90% of the triglyceride is converting. So we have been given that we have 12 kg of bio oil, and out of this 12 kg it has 90% of triglyceride. So we'll calculate how much there is triglyceride in the oil. So it will be 12 into 0.9, that will be 10.8 kg. And next we will calculate the molecular weight of the triglyceride to find out the number of moles of triglyceride. And then from there we will find out the how much mass of triglyceride is converted to glycerine. It is given that 80% is conversion, so we will calculate how many moles is converting. So it is around 11.966 moles. And then we will calculate amount of glycerine produced, because 1 mole of triglyceride is giving 1 mole of glycerine. So 11.966 moles will give 11.966 moles of glycerine, and the molecular mass of glycerine is 92, so we are getting around 1.1 kg of the glycerine. So A is the correct answer. So let's move to the next question. So the question is, which of the following is not an example of saturated fatty acid? A, capric acid, stearic, myristic, or oleic. So I'll give you 2 minutes to just write the correct answer in the chat box, and then we will see which is the correct answer. So folic acid, it is not a saturated fatty acid, so D is the Correct answer, rest, capric, stearic and myristic acid are the saturated fatty acids. So let's move to the next question. So the question is 100 ml bio oil sample is reacted with 81 gram of iodide monochloride. After reaction, Ki is added in it and the liberated iodine is titrated with sodium thiosulfate. If point if zero point 0.2 mole of sodium thiosulfate is consumed to reach the titrate value, determine the iodine value of the oil. So, Abhinav, regarding the question format, I think the type of questions which you are solving in the assignment problems, the question pattern will be similar to that only. And regarding the weightage, I do not have any information about this. You can mail to the NPTEL support team. Regarding the question format, please mail to the NPTEL support team, or also you can raise your question. There is a section to ask your queries. You can ask there, and also and someone from the support team, they will reply you regarding the pattern and weightage for each part. So let's try to solve this question. So I'll give you 5 minutes to just take your time and write the correct answer which you are which you are getting in the chat box, and then we will see how to solve this question. So the correct answer is 50, 57, I guess. So let's see. So ICl will react with Ki to give KCl and I2, and this excess iodine. So the excess ICl will react with Ki to form iodine, and which will be further converted to iodide ion by titrating with sodium thiosulfate. So it will give 2NaI plus Na2S4O6. So after balancing, we are giving 2 here. So from this reaction, we can see that each mole of iodine reacts with 2 mole of sodium thiosulfate. So in question, it is given that 2 mole of sodium thiosulfate is consumed. It means 0.1 mole of iodine is titrated. So here we can see 1 mole of I2 requires 2 moles of sodium thiosulfate. So 0.2 mole of thiosulfate, it will react with 0.1 mole of iodine. So it will be so the molecular weight of iodine is I think around 127. It is 126.9. So for I2 molecule, it will be 253.8. So it is we are getting around. So we are getting around 25.38 grams of iodine. So this much amount of iodine is reacting with 0.2 moles of sodium thiosulfate, and iodine present in original solution is so it is given that 100 ml of bio oil sample is reacted with 81 gram of iodide monochloride. So it is 81 into 126.9 divided by 162.35. So in molecular weight of ICl is 162.35. So in 1 mole of ICl we have 1 mole of iodide and 1 mole of chloride. So so the amount of iodine, it will be 126.9 divided by 162.35, and we have 80 grams of iodide monochloride. So in 162.35 grams of iodine chloride, we have 126.9 grams of iodide. So in 81 grams, so we will have this much of iodine. So on solving this, we are getting 63.31 grams. So the iodine used will be 63.31 minus 25.38. So it's coming out to be 37.93 grams. So nearly it is 38. So the iodine value will be 38. That is D. So in this question, we have been given initially how much of iodine is present, and then we will see how much sodium thiosulfate is consumed to reach the titer value, and this will be the amount which is remaining. So initial amount minus the remaining amount will give us how much iodine is used, and this will give us the iodine value of the oil, which is 38. So it is around option D. So let's move to the next question. So the question is, which of the following is not a type of closed system photobioreactor? A. Vertical tubular, B. Horizontal tubular, C. Plastic bag system, or D. Raceway pond. So I'll give you 2 minutes. Just take your time and write the correct option in the chat box. So D is the correct answer. Vertical tubular, horizontal tubular, and plastic bag system. All these are the closed system. And raceway pond, this is an example of open system. So D is the correct answer. So let's move to the next question. So the question is, flat panel photo bioreactor typically have a width of dash centimeter. So this question is directly from the slide. So we have to write what is the width of flat panel for photo bioreactor. So again, I'll give you 1 minute. 1 minute, just write your correct answer in the chat box, and then we will see which is the correct one. So B is the correct answer, that the width is 3.2 centimeters. So let's move to the next question. Among the following algae harvest method, which one has relatively low cost? A. Inorganic chemical flocculation, polyelectrolyte flocculation, C. Gravity sedimentation, or D. Flotation. So again, I will give you 1 or 2 minutes. Just take your time and write the correct answer in the chat box, and then we will see which is the correct one. So C is the correct answer in A. B. It is a chemical method for harvesting of the algae in which flocculant and polyelectrolyte, that is polymer, is required for flocculation, and last is deflotation, and it is also costly as compared to the gravity sedimentation. So in gravity sedimentation, the algae settles at the bottom of the reactor just by gravity, and that's why it is relatively lesser costly than other three method. So C is the correct answer. So let's move to the next question. So the question is, which of the following catalyzed trans-esterification process is or are used for biodiesel production? A. Homogeneous base catalyst, B. Homogeneous acid catalyst, or C. Enzyme catalyst. So again, I'll give you 1 minute. Just take your time and write the correct answer in the chat box. So homogeneous base catalyst, homogeneous acid catalyst, and enzyme catalyst, all these are used for biodiesel production. So D is the correct answer. So the next question is, which of the following statement is not true about microwave technology assisted catalyzed transesterification? A. Energy requirement is less. B. Scale up is so easy. C. KOH is used as catalyst. Or D. None of the above. So in microwave assisted catalyzed transesterification, energy requirement is less, scale up is easy, and KOH is used as catalyst. So all these statements are correct about microwave technology for transesterification. So D is the correct answer. So the next question is, which of the following is not a type of homogeneous catalyst used for the upgradation of algae oil to biodiesel? A HCl, B H2SO4, next NOH, or D CaO, calcium oxide supported on aluminium oxide. So again I will wait for 1 minute, then we will see which is the correct answer. So D is the correct answer because HCl, H2S4, NaOH, all these are the homogeneous catalysts. Their phase are similar to the alkyl oil, other than but D, that is the COA supported and Al2O3, it is phase is different from the alkyl oil. It is solid. So D is the correct answer. So let's move to the next question. So the question is, which of the following algae harvesting technique has highest total suspended solid yield? A. Flotation, B. Centrifugation, C. Polyelectrolyte flocculation, or D. Inorganic chemical flocculation. So again, I will give you 2 minutes. Just take your time and write the correct answer in the chat box. So the correct answer is inorganic chemical flocculation. So in this, some flocculant are used which coagulates with the algae and they form flocks and then finally settles at the bottom and then from there it is harvested. So this is the highest TSS yield. So let's go to the next question. The question is the compounds A and B in the following trans-esterification reaction are. So triglycerides react with alcohol to give A and B. So what is A and B? A can be aldehyde or B can be acetic acid, ethers or glycerol, esters or glycerol, or D esters or and B acetic acid. So again we'll wait for 2 minutes. Please write your answer in the chat box and then we'll see which is the correct one. So C is the correct answer, that triglycerides and alcohol reacts to give us esters and glycerol. So C is the correct answer. So let's move to the next question. So the order of reaction for esterification reaction is A. So these four options are given. So again, I'll give you, so we have to find out which is the order of reaction rate, which is the highest reaction rate, base catalyzed, enzyme catalyzed, or acid catalyzed. So we have different combinations and we have to find out which is the correct order of reaction rate. So again, I'll give you 2 minutes. Just take your time and write the correct answer in the chat box and then we'll see. So B is the correct answer, that the highest rate of reaction rate is in base catalyzed, followed by acid catalyzed and then enzyme catalyzed esterification reaction. So let's move to the next question. So the question is the operation A in bio-oil production from algal biomass is. So we have been given a flow chart. We have to identify what is the operation A, whether it is extraction, distillation, evaporation, or defiltration. Again, I'll give you 2 minutes. Just take your time and write the correct answer in the chat box. So A is the correct option. So during biooil production, the harvested microalgae are first dried, and this dry algal biomass are extracted to, for the oil, and then after the extraction of the bioil, it is further separated and then further modified. So A is extraction. So let's move to the next question. So the question is, so again it is a numerical type question. So we have solved similar question, very similar question, which was the question number 1 of this session, problem solving session. So the question is, bio-oil extracted from an oil seed sample has 85% triglycerides containing 3 long chain which can produce methyl esters of lauric acid, myristic acid and palmitic acid in equal molar ratio during trans-esterification using methanol and NOH catalyst. Calculate the amount of biodiesel produced by trans-esterification of 8 kg of bio-oil. Assume efficiency of conversion is 75% and 12% of palmitic acid is converted to soap. How much glycerol will be produced? So we have solved a similar question just now. So I'll give you 5 minutes. Please try to solve this question and write the correct answer. So these are the options. Please write the correct option or value which you are getting in the chat box. So this is the question. We have to find out how much cholesterol will be produced. So the formula for the oil will be, so this is the formula for the oil. It will react with methanol to give glycerol and biodiesel compounds. So glycerol will be, so this is glycerol. So first we'll find out the molecular formula of triglyceride. So its molecular weight of triglyceride will be 722 grams. We have calculated in question number 1. And molecular weight of glycerol, it will be 92 grams. We have calculated this in question number 1 also. So let's move to the next slide. So here it is given that 8 kg of bio oil, and also it was given that 85% of the bio oil is triglyceride. So amount of triglyceride, it will be 85% of the total oil. So it will be 8 into 0.85, which is coming out to be 6.8 kg. And the mole of triglyceride, we have 6.8 kg divided by 722 grams per mole is the molecular weight. So after solving this, we are getting 9.418 moles. And moles of triglyceride converted to glycerine efficiency is given as, I think, 75%. Assume efficiency of conversion is 75%. So 75% of this number of moles will be converted to glycerine. So it's coming out to be 7.0635 moles. So glycerine produced, so it is 7.0635 moles of glycerine, and in the previous slide we have calculated that its molecular weight is 92 grams. So to convert it into kg, we'll divide it by 1000, and we are getting around 0.65 kg. 0.6498 kg of glycerine is produced. So 0.65, C is the correct answer. So let's move to the next question. So this is the continuation of the previous question. We have to find out how much soap will be produced. Okay. So I do not know how many questions will be numerical or how many will be theoretical. So I do not have any idea about this. Also, whether it will be MCQ based or writing type. Questions will be MCQ based only. There will not be questions will be similar to what you are getting in the assignment questions. So regarding the, okay, so if you have any other doubt, you can mail to the NPTEL team, or also you can raise your question in the portal. Surely will get a reply and your doubt will be cleared. So next part is how much soap will be produced? So for reaction of I think it was given that palmitic oil is converted to. So the question is given that 12% of the palmitic acid is converting to soap. So palmitic oil acid is C15H31 COO CH3. It will react with NaOH to produce soap, that is C15H31 COONA and CH3OH. So I don't know about this, like how many questions from assignment will come. So I have no idea about this. So the molecular weight of palmitic oil is, so I'll calculate its molecular weight. It will be 12 into 15 plus 1 into 31 plus 12 into 1 plus 2 into 16 plus 1 into 12 plus 1 into 3. So it will be 270 grams. And molecular weight of the soap produced, its molecular weight will be 15 into 12 plus 31 plus 12 plus 2 into 16. For sodium it is 23. So it will be 278 grams. Now we have to calculate how much soap is produced. So before that we have to find out like from the total mass how much palmolic so mass of C15H31 COOCH3 produced, it will be total moles of glycerol produced, so which was coming out to be, I think it was 7.0635. It was 7.0635 moles of glycerol. So its molecular weight is 0.27 into 0.88 because 12% is converting to soap. So the rest will be converted to biodiesel components. So it will be 88 percentage, so 0.88. So it's coming out to be, so let me calculate it. So we can also calculate directly like how much of palmolic acid will be used for soap formation by directly multiplying it with 12% because 12% is getting converted. So let's multiply it with 12. So let me calculate it. So it's coming out to be 0.2288. So this much amount of palmolic acid will be used for soap formation. So from here we can see that around 278 grams of soap is formed from 270 grams of palmic acid. So from 0.2288 kg of palmic acid, soap produced will be 0.2288 into 278 divided by 270. So which is coming out to be 0.2356 kg. So this much, where is the question? So this much amount of soap will be produced, 0.2356. So C is the correct answer. So these were the questions based on assignment, sorry, week 8 material. So this was the last problem solving session. So if you have any doubt, then you can ask. So your exam is on next week, so all the best for your exam. So the question pattern will be similar to what is asked in the assignment. So there will be no subjective type questions in which you have to write the answers. So it will be objective type only. So at max there can be NAT type questions where you have to write the values. I'm not sure about this. So all the best for your exams. If you have any doubt you can ask, or otherwise we can end the session here. So I think there is no doubt. Okay. Okay, thank you so much for joining. Have a nice day and all the best for exam. Thank you.